Hi and welcome back. This is class 14 of this series of tutorial. And in this class, we are going to talk about the shading. We are going to go inside the material network here and talk a bit about the pyro shader and how to improve the look of the smoke with this shader. Before we get started, just go to the mantra ROP and make sure that you have some sampling quality, which is relatively low so that it's good enough to see the result but not too slow to render. Okay, right now I have a 13 seconds render time and I will go with that. This is a default I use for this class 14 start, so if you have the file then you should be good to go. Also, and I should have mentioned that before, and sorry about that, go here into the render view, press D, okay, and go to background here. We are going to define the background image that we have for the compositing so that we can see actually what's happening during render time. So here, go to render background or whatever image you have for your background and press accept. And here, accept again, okay? So now it's displaying the image on the background. It will be easier to actually tune the lighting and the shading on the actual image. And if you want to deactivate it, no need to go back to the display options here. Go simply here into just add this, okay? Open it, the display options, and then go to the background image. You can toggle it on or off. You can also toggle the transparency, and that would do the job as well. So we have built our setup with the pyro shader in order to be able to render the smoke with Mantra. But so far we only have been using the density scale and the shadow density. I ask you to put the intensity scale for the fire to 0 with the temperature scale here, because we have no temperature nor heat, so we don't need them. And then we leave the rest untouched, okay? So before getting into the other parameters, I would like to tell a few words about the pyro shader. This is a digital asset, okay, which is built onto other assets there, and mainly onto the pyro shader core. If you want to do your own shader, you could definitely go and lay down the pyro shader core, okay, and work directly with this one. All right. This one you cannot go inside it. Okay, it's really a core shader as it mentions. But basically, the advantage of using the pyro shader here is that you already have some tools that are built for you and are helping you define the look of the smoke. So the first parameter we've used is the density scale. Okay, the density scale, and it is said in the documentation, is really a multiplier that multiplies all the values that we set here and here on the smoke tab at the end. Okay, if you want to check that, then we are going to go inside the shader, and for that I'm going to use a separate view. Okay, so we have here the shader that I can select and play with, and here we are going to dive inside the shader. So I'm going to allow the editing of the content so we can actually see the entire workflow here. And if you dive inside, you have here a density scale, which is multiplying the entire process, which is there before, okay? There you have smoke density. So all this is dealing with the smoke density. And really at the end, you have the density scale multiplying the entire algorithm that we have just before. Here it's about the smoke color. Here the fire intensity, which we are going to ignore, and the fire color. They really don't interest us. Okay, so the density scale is really a multiplier that comes at the end of all the things that we are doing here, and I think the shadows as well. Okay, so anything that is happening here, the shape and the noise, which we are going to see later, is going to be multiplied by this one. This is the master scale for the entire shader. The next thing you want to play with is probably the smoke color, all right? So far it is white. Maybe I actually was not the right process. I should set up the color of the smoke before actually lighting everything. So I went to my lights here and I set the color for all the lights to white. So we have a neutral lighting, and here same on the shadow, I put the shadows to black, okay? And so I did a new render, and this is what we have now. So kind of a white grayish color. And if I go back to my dust, then you can change the color. And I'm going to use the background color as a start. So go here and where's it there? Paste the values. Now we can snap and do a new render. And so it changes drastically the look of the smoke here. So either you go to the color here and then you increase the color, the value, and you reduce the saturation to get something which is colored but without what we had before, or you go here and you actually increase the smoke brightness, so it's going to make the color of the smoke a little brighter. And this is the result. Okay, the smoke brightness is really multiplicating the smoke color here. You can see it in the help. Sorry, there you can see the help telling you that it's actually multiplying with the smoke color and the CD volume if you're actually using the CD volume, which is here. Okay, where do we see that here? Okay, this is what's managing the color. So we have a switcher, whether we use or not the CD field. And then you have some multiplication here. But we don't see any smoke brightness multiplied here. We don't see this parameter. This parameter here is called s_int. And if you look for it, it's not really obvious. You cannot look with Control F. It's there. It's the K smoke. So if you open this, you see that we have here the K smoke, and this is called sint. This is the one that is inside the shader core here, multiplying the smoke color, the final smoke color, which is the multiplication of the smoke color and the CD field, okay? And it's doing it onto the shader core. Another thing regarding the smoke brightness, put that back to 1 and fire up another render. So you see that the smoke here is almost disappearing, okay? It's like darker. Now go to your lights and put all the lights, multiply the intensity here by 10, okay? So 1, here it's going to be 5, and here it's going to be 5 as well, okay? And now just snap this one and launch a new render. And you see we are getting back the level of brightness that we had before, okay, here. Then we had this when we removed the smoke brightness. And now with the smoke brightness of 1, but multiplying all the lights by 10, this is what we have, okay? So really here, this smoke brightness here is affecting the color, but it's also affecting, well, the lighting, or is affected by the lighting. All the 3 values, smoke brightness, color, and the lighting intensity here, what you have here, or I mean, in combination with the exposure, it's all related, okay? So you can tweak things either on the shader or on the lights. If you want finer control, individual control, you go for the lights, okay? And if you want a global control, maybe you can go to the smoke brightness. Then you have the shadow density. If you put 10 here, you see how it influences the render. And so it makes all the shadows darker here. It's pretty much the same way as the lights is doing it here with the shadow intensity, remember? Except that it's doing it in a more general way, okay? It's like a global parameter that changes the entire shadow density for everything, for the entire smoke. So if you want a finer control, you go here per light, you can define which shadow density you want to have, and same here for the key, you can have an independent one. But if you want something which is more global, then you can go onto the shader directly. And now one last thing, if you want to see where it is, you Control F here, shadow. You have the C shadow and the K shadow. Okay, it's not really obvious, but they are directly plugged into the shader core. And if you go to the K shadow here, G, and this is the shadow int. If you go here, shadow int, okay, this is the parameter that is used. And so you have this here, and you have obviously the shadow color, which is there as well. Okay, so you both have both of these parameters are going directly into the shader core. And then we have the scattering phase here. The scattering phase is really an interesting parameter. It's going to help you give the sensation we have some scatter inside the volume and how the scatter is controlled inside the volume. With a value of 0, you can see that with the help, all the directions are going to be equally considered. So when the light is entering, let's say we have this key light here, it is entering the volume, then it's going to be bounced in all the directions. There is no privileged directions for this light with a scattering of 0. But if we go with positive values here, then the light is going to be scattered more and more into the same direction as the incoming light. So here with the key light, it's going to be bounced a little bit backward, but more and more it's going to go in the same direction as the light, okay? And we are going to have less light going backward. And if we go with negative values, it's the opposite. More and more light is going to be bounced backward towards the source of the light, and less is going to go through the volume. So with positive value here, this is what we have. And you see now, if we compare both renders, that we have more lights into the shadow area, okay? More light is scattered. This is the previous one. This is the new one. More light is scattered inside the shadows area, okay? And here, if let's say I do the same value, but with a negative value now, I stop and I render. Now the light is bounced backward, okay? So we only have this here and less in the shadow area. And when we compare, you see that it's actually increasing the contrast a little bit here, okay? So the scatter is really going backward inside the volume. Now, if we consider a little bit of physics, the volume you are simulating should help you decide which scattering phase you want to use. Let's say you are simulating some steam, for instance, or a cloud. They are made of water. Both are made of water, particles of water, droplets. And the water is transparent, and the light is really going through the water, right? So in this case, I would probably use a positive scattering phase so that the light coming in would be scattered forward. In our case, we have dust, and dust, the particles of dust are opaque, okay? And so the light is blocked by the particles of dust and bouncing backward. And in this case, we are using a negative scattering phase, okay? So think about it. Depending on the volume you want to simulate, this is a good helper to choose what scattering phase you want. Now, in the smoke field tab here, we have two tabs, the shape and the noise, and we are going to use them to further improve the look or control the look of our smoke. Now, go to the smoke field tab here, okay? This smoke field is really controlling the density volume, or actually any volume that you put in here, but in our case, this is the density. And you can see two tabs, okay, the shape and the noise. And we are going to use this to further control the look of our density volume. On the shape tab, you have various options. You can see here, and you can check them on, off to actually activate them. Those options here all come from this reshape value VOP. And if you dive inside the reshape value, you can see that you have the fit part, which is here, and you can activate. You can have the ramp here. Here you have the contour, the soft clip, the limits, and finally the final amplitude, which is the final scale here. Okay? So the first option we have is the fit to range. It's basically taking a source range, so the actual density we are fitting in, and the values that we are giving and fitting them into some target range, okay, like the fit function. If we look here, we have the init value, which is the density, which is coming in, okay? And then we have the min max, which is the source min max, and then the destination min max that goes into here, okay? So this is really the fit that we are going to use. And so to be able to fit correctly the smoke, you need to know the minimum value and the maximum value. The minimum value is quite obvious, is 0, because anywhere you don't have anything where it is 0, okay? But the maximum value is not that obvious, okay? And the way I get to know the maximum value, you can use this volume max function, all right? And if I press F1 on this. Come on. Okay, it doesn't get it. All right. Well, the way you can use this function is that you get the actual object, and here is the I go to dust, and then inside dust I go to render, because it's the dust I want to render. Okay, this is the object, and then in here I say which is the float here is the primitive number of the volume I want to render, and the primitive number of the density is 0. Okay, and now if you go to the expression, you toggle the expression, now you have the value of this maximum. Okay, this is the maximum value of the density inside this volume. Okay, but this is the maximum for this frame. And now if I move that, you will see that we have a different maximum here. And so the maximum value is probably at the beginning here, at the moment of the impact, where we have emitted the entire density in there. And then the density is going to be spread, and it's going to dissipate, it's going to be diffused inside the container. So it's probably going to be decreasing because we have no more emission in there. So the maximum of the emission might be at the very beginning here in the first few frames. And you can see here at frame 32, we have a value of 274 here. All right, so we can use that. And then that means that anything between 0 and 274 gets remapped between 0 and 1. Okay, and so if we go toward the end now with this value, okay, of 2.74, then we are going to have something which is less dense than this. And this is what we have. Now, why do I want to do that? Is because to be able to use the rest of the chain here, okay, the rest of the network, come on, okay, I want to normalize my values here, okay, because then when I use a lookup ramp here, the input is going between 0 and 1, and I want to be sure that the target range here is between 0 and 1. So I want to make sure that my maximum value that is passed here inside the ramp is going to be between 0 and 1. So I actually know what I'm doing here. Otherwise, if I have any values that is above this range, then I cannot control what's happening to them. So if you want to compensate for this loss here, you can come here and multiply by 274. And so compare that with the previous render, we have exactly the same, okay? So you compensate for this change by multiplying here the final scale with the same value. But now the difference is that we have a target range which is normalized, and so you can use all those options in between. Remember, the final scale is not applied there, it's applied only here at the end. Final amplitude, this is the final scale here. You see it's called amp, and this one here is called amp. All right, so this is the one that is multiplying the final density before it gets output here on the reshape value node on the output. Okay. And now if I activate the ramp, then I can actually further control the shape of the curve, the shape of the density. So the input here is between 0 and 1. And to double check that, go in here inside the reshape value, and you see that in this digital asset, the ramp is coming inside a ramp filter, and the min and max here, if I select them, press P to display, the range is between 0 and 1. Okay? So I recommend you normalize this here so that it goes into the ramp between 0 and 1. You can obviously put 2 or 10 or something like this, but then you would have the range here would be going beyond this value, and really you would be changing only this a portion of your range. Okay, so be careful with that. Another way of doing it would be to come inside here, actually go here, go one level up, allow the editing of the content. Okay, so you break the digital asset, and then here, instead of having something between 0 and 1, which is here, you come here and you plug the min and max of the destination here. So you take this, okay, and you make some dots just to make it go all the way to the minimum. And then here, you take this, you make some more dots, and you go all the way here to the range maximum. That way, the values you put here inside the target range are used as well in the ramp filter here as the minimum and the maximum of the input. Okay? So that you have two ways of doing this. Now I'm going to go back to the current definition. Okay? And dive in there just to show where we are. We are now here. And so here, if I go and change a bit the parameters, maybe do that. And so by changing the shape of this ramp here, I could get rid of some of the values that were really, really low here. I had to change the actual value here compared to what I said before pausing the video, because we have really, really low value. If you remember, at this frame 100, we don't have 274, we have 0.11. Let's volume max, yes. So it was dust render, and then it was the density volume. And then if we look at here, we have this. So I'm going to break this, and here I'm going to just leave it to 1. Now we have this render here, obviously because we changed the range from 0.11 to 0 to 1, sorry. I cut a bit here, but if I go even further now, then you see we are actually cutting all the low values here. And if you want to compensate, then we need to multiply by the final scale of 11, 3, or even 3, 9, if you want to be precise. Now we bring the entire density down to this, this low value that we had before. Okay, definitely not what I want here in this case, but I wanted to show how the ramp is working. You can also obviously here change this for something which is a B-spline. So if you go here and put some more points there, you have some curvy, more curvy curve, and you have an S-shape curve that you can use like a contrast. Okay, so I'm going to deactivate the lookup ramp here. And I don't want to use the fit range. I want to go back to my previous render so I can show you how to use the contour. Now, if you want to use the contour, if you activate it here, you won't see anything inside your render. This is because there, where the contour is actually set up, it goes inside a two-way, but this two-way, unlike the others, don't have any condition in there. So we need to put the condition there. I believe this is a bug. I reported it. It would probably be fixed in the future versions, but as of 3.9.1, this is what we have inside the reshape value of the Pyro shader. Okay, so to fix it, you need to go here, allow editing of content, and you need, what I can do is just move this, and this is interesting to learn anyway. So you open this and you go, so we need the contour enable. You see the name of the parameter, contour enable. So we need to find it, and it's there. And then you plug it here. All right. And now it's plugged. You can press this. So we have just this sub input here. All right. And now here you would have it activated, and you can see it inside the render. And so this is what the contour is doing. It's coming here at the low, the values at the bottom of the range, and it's clipping them, or it's actually chewing on them and reducing them. If you compare to before, this is what we had, and this is what we have right now. So if you have some low value here that you can't get rid of the noise, and actually it's not good for the look of your smoke because you want something really dense, but you still have some values there, go with the contour, or the lookup ramp actually can do that as well. But the contour is a fast and easy way to actually come in and clip those values here. Okay. Now, the soft clip is doing the exact opposite of the contour. While the contour is working on the bottom of the input range, okay, so it's increasing or decreasing contrast at the bottom of the range. The soft clip is doing it for the top of the range, okay? Remember, at this frame, we have something going, the maximum density is 0.11, all right? So if I want to cut something, I have to go really, really low. And I'm going to exaggerate here. And I'm going to suppress something like big, so we actually see the result. And so I'm going to stop and press render. And this is what we have. If we compare with before, okay, it's really subtle, if you see it. And so for the high density values, we removed a bit. We came here and soft clipped the actual density values that we had here. And finally, the clamp here, well, you know what it does. It just clamps the values. The final values here, so the final values in the chain are clamped and then multiplied, as I said, by the final amplitude, which is the final scale here. Okay, so I'm not using that in my case here, but you might want to use this in case you need. Just know that the reshape value, there is just this little bug here where you need to activate the contour inside the reshape value. Okay. And now the last part of the pyro shaders that interest us on the smoke field tab is the noise. The noise needs two fields to be able to work properly. If you go inside the dust here, the noise is added with this unified noise, and it's either multiplied or add to the output density from the reshape tab. Okay, but this unified noise uses the position here to be able to define the noise. Okay, and this position, it comes from this dual rest solver. And for that, it needs the rest field and the rest ratio, which is an attribute, and a rest2 field and a rest2 ratio. To add those fields to the simulation, you have to go inside the simulation network here. And first go on the object. On the initial data tab, go here and add rest field, okay? Then on the solver, go to the advanced tab, rest field, and enable the rest field. All right. Now, when you simulate again, you should see after a few frames. Okay, so I should go here so that we actually have the simulation enabled. Sorry, and it's actually faster. All right. So now you go here, and if you middle click here, you see that we have rest2 and rest added to the simulation. Of course, then you need to cache them. So you go here, and onto the import field, you add them as fields. You can, if you choose the smoke by default, you only have rest. If you choose the pyro, you have rest and rest2, and so you can get rid of the rest, of the other fields and keep the rest and rest2 fields. And so to show you how those fields are working, I created this new scene with a sphere at the origin with the Autodub network. This is what it's doing, okay? And so inside here, I imported my fields and I separate the rest here. And with a volume visualization, I set to density and rest. I visualize my rest field on one side and here my rest2 field. Okay, then I do some transformation to have them one on the left, one on the right. Then I blast the other volume. So I only keep the volume that interests me. And same here, I keep rest2. I have to do some edit here. I need to change the name of the attribute because when you merge this, if you don't do that, then you're losing the color. And if we look at them here, you see that one of them is resetting while the other one is advecting. So basically, if we go from the start, it's advecting, the position. This is the position. The color we see is the actual position at the initial frame here. And then we advect the position, okay? But obviously, if we advect the position indefinitely, then the position would get stretched. And so the noise that we have inside here, here on the shader, and inside the dust, we are going to the unified noise. Because it used the position that is stretched, the noise will be stretched, okay? And that would not give any as a result interesting. We would see the stretch inside the noise. We would see the artifact. So what we do to compensate for this is that we send these two rest fields, okay? One starts first and the other one starts with some offset. Actually, no, they start at the same time, but then one is reset here at frame 27. So it's half the actual, if we go in there, you go to the pyro solver, you have the frames between solve, okay? So it's 50. So at half 50, which is 25 roughly, if I go here, so it starts at 20, it starts at 1, so plus 25, 26 it stops and then it gets reset, okay? And then if we go further, look at what's happened at frame 50, then it's the first one which gets reset. But in the meantime, this one gets advected. And so on and so on. You will see them jumping each other in time. Okay, you will have now this one on the left, which is reset while the other one is going up and still advected. And then it's reset while the other one is advected. And so the dual rest solver that we have here, okay, is using this field rest and this rest2. And thanks to the ratio we have here, the attributes ratio, it's going to know how to blend them. So it's going to blend them together. And if you blend this one and this one by fading this one off before it snaps back to 0, and then fading this one on at the moment it gets initialized, then you will get something which is continuous. And hopefully, if you fine-tune correctly your values here in the frames between solve and the frame offset and the advection rate, then you would get something smooth and you won't see anything during the render time. One thing I forgot to mention about the rest field here, don't forget to set the frame offset to be exactly the same frame, start frame as the DOP network, okay? Because otherwise the initialization won't work properly. The rest field would be initialized at frame 1, but then the simulation starts only at frame 31, so it won't get any information inside there, and there will be a problem. Let's go back to the rest field setup that I prepared. And on the DOP network, I set the start frame to 20, but inside I set the frame offset to 1. And so if we go back up here and I press play, this is what we have. So you see something is jumping here, we have black, and now we have something, but the simulation started already. All right, and then we have something. And now after a few cycles, it properly initializes. But that's wrong. I mean, the first 20 frame, the first maybe 60 frame are completely wrong. And only there, frame 80, it starts working, okay? So be careful with that. And so here, if I set 20, but inside I set 20 as well, okay? Now I press play. Now you have this, which is set correctly. So I cached the simulation with the rest field. And after I cached the simulation, I went to the shader and I activated the noise. Okay, and I did several renders. So the first render here is without the noise on the Pyro shader. This one here is with the noise enabled as multiplied and with a frequency of 3. Okay, the first one is 3. And then you had this one with 4. And then this one with 5, and finally this one with 6, okay? And so you can see that it's adding some interesting details inside the smoke, okay? It's moving with the smoke. It's not a static. It's not a static texture that is staying inside the container, and this is thanks to the rest field. Now, it's not breaking the shapes, the mushroom shapes we have here. To break them, we definitely need to go inside the simulation. But at least we see it's adding some more holes into it, some interesting patterns that is making it looking a bit more like a smoke, and it's moving actually with the smoke. One thing that you can do to help you define the frequency for your noise. Instead of doing too much renders, trying a little bit more, a little bit less. Go all the way up here and use a grid that you position close to your smoke, okay, with the same distance from the camera. Get inside and use an attribute VOP. Okay, we use the attribute VOP because on the shader we have the unified noise which is used to define the noise. So plug the position into the position here and plug the noise into the color. That way you can see the frequency of your noise. And so here I'm going to go on mouse up. If you increase this to 4, this is the pattern we have. If I go up, and then I can see with my smoke, that would be the pattern of my noise multiplied with my smoke. So if you go back here, then inside you can increase maybe to 6 and go back up, and this would be the pattern of your noise onto your smoke. Okay, so this is a quick way to actually define the range you want to try for your simulation, and then you go back to the dust here and you say, okay, at 6 I have something interesting. Maybe I'm going to do 5, 6, 7, 8, or 4, 5, 6. But at least you get to know a correct range for the value, and you don't have to do too much renders. And this concludes class 14 about the Pyro shader and how to use it to shade your dust simulation. We've seen that we can use it to change the density after the simulation. And we've seen a couple of other things like the shape tab, where we can use some tricks to filter out or in some of the interesting values that we have inside the density field. We've also used the scattering phase, and this one is necessary if you want to have the light scatter in some direction inside your volume. Okay, so this helps you define the scattering of the light inside the volume. And finally, we added some noise. This noise, we've seen that we needed the rest fields onto the simulation, so we have to go on the simulation network and activate the caching of the rest fields. And then these rest fields are used for the noise because it helps having a noise which is not static inside the volume. It's not like a 3D static texture. It's actually moving, advected with the simulation. And so we can see the noise evolving with the simulation instead of being static inside the container. Well, that's it. Thank you for watching, and I see you in class 15. Goodbye.